All right, so as I said, we're going to learn several different ways to solve systems of linear equations. We've talked previously about what a system of linear equations is and what the solution to a system of linear equations looks like. And today, we're going to learn one of the ways to actually find the solution, which is by graphing. So let me start off by giving you a really basic system of linear equations. We will get progressively more challenging as we go. But let's start off with that system of equations. And so in order to solve a system of equations by graphing, the first thing that we need to do is graph them. So the easiest way to graph a system of linear equations is to put the equation in slope-intercept form and then graph it. Slope-intercept form is the easiest way to graph because it gives you a starting point, which is the y-intercept, and then it also gives you the slope, which allows you to get the second point that you need. Now, luckily for us, our first equation is already in slope-intercept form. In that equation, what is the slope? Negative 1/4. The b value is 1, which means the y-intercept is the coordinate 0, 1. So that's pretty simple to graph. I can do a really rough sketch here. We're going to do it using technology here in just a minute to get the exact answer. But I can do a really rough sketch, which is that I'm going to start the graph at the point 0, 1. And I'm going to estimate the slope of 1/4, which would be down 1 and over 4. That would put my point at 4, 0. So I'm just doing, this is a very rough sketch. This sketch is just going to show me what the lines look like. It's not going to help me get the answer. We'll have to use technology to get the answer to graph it, either a graphing calculator or Desmos. But that's roughly what the first equation is going to look like. Now, the second equation is a problem because it's not in slope-intercept form, but I can get it there. So we're going to take that x minus y equals 4, and I think the first thing we should do probably is subtract x from both sides. That will help us get the y by itself. That'll give us negative y equals negative x plus 4. I cannot combine the negative x and the positive 4 because they aren't like terms, so I'm going to have to leave them separate, just like that. This is almost in slope-intercept form. What's the one thing that is keeping this from being in slope-intercept form? Why is this not in slope-intercept form right now? Slope-intercept form must be y equals mx plus b. Is that what this looks like? Why not? Oh, I disagree. The slope right now looks like it's negative 1, right? Negative 1x. Why is this not y equals mx plus b? Yeah, because the y is negative. Exactly right. So how am I supposed to get rid of that? How am I supposed to turn that negative y into a positive y? Multiply it by what? How can I turn a negative into a positive without actually changing the number? Timesing it by 1 would still give me negative y, but what if I times it by negative 1? Yeah, what if I multiplied everything in this problem by negative 1? It would also be possible to divide everything in this problem by negative 1 and get the same effect. Huh? Page 3, slide 2. So that give me y equals positive x minus 4. And that's a little clumped up there, so I'm going to write below what I did. I multiplied everything by negative 1. Multiplying by -1 just has the effect of changing all of the signs. All the negatives become positives, all the positives become negatives. So I got y equals x plus 4, that's nice. Now I can tell you what the slope and the y-intercept are. What is the m here? What's the number in front of the x, or the coefficient of x? 1. And the value of b is close, not 4, -4, because of that minus sign, which means the y-intercept is 0, -4. So again, I'm going to estimate 0, -4, right there. A slope of 1 means up 1 and over 1. So up 1 and over 1, up 1 and over 1, up 1 and over 1. So it looks, from my incredibly rough sketch, like the solution is that 4, 0. Keep in mind, this is not a super accurate sketch, but I think the solution might be 4, 0. I'm going to put a question mark there because I'm not sure. From my sketch I did, it sure looks like it's 4, 0. The way that I can tell for sure, though, is by graphing using either a graphing calculator, or if you don't have a graphing calculator, you can use the Desmos website, which we've used before. So go ahead and open up a window to Desmos, or if you have a graphing calculator, I recommend you use the graphing calculator if you have access to one, because the graphing calculator is the tool that you'll be allowed to use on the STAR exam. So if you have a graphing calculator, I recommend it. If you don't, use Desmos for now. On the graphing calculator, you would press y equals, and you will see y1, y2, y3, y4, all the way down. And you'll put the first equation into y1 and the second equation into y2. On Desmos, you just go to this first block right here, and we'll put in the first equation, which was y equals -1/4. I'm going to put that in parentheses, -1/4, x plus 1. So there's my first equation. Looks kind of weird with the negative right there. I'm going to put the negative out in front. I think that looks, same equation, but it looks a little nicer with the negative out in front, I think. And my second equation was y equals x minus 4. On a graphing calculator, the way that you will find the intersection is by pressing the buttons second, trace, 5. Trace is one of the little narrow gray buttons up at the top. Second, trace, 5. That's the intersection. And then press enter 3 times in a row, and it will tell you the solution. In Desmos, it actually grays out the solution right there, and you can see, voila, the solution turns out actually is 4, 0. So my little sketch was not bad. You should never, ever, ever base your sketch off of, or base your answer off of your sketch. That is not a great idea, because your sketch is probably not going to be the most accurate thing in the whole wide world. Always use a calculator or technology of some kind. So now I'm going to go back to my notes, and I'm going to erase this question mark because I just confirmed that 4, 0 is the answer. So the solution then is the coordinate 4, 0. That's my answer. So I'm going to make sure that I box and highlight and color and otherwise indicate that's my answer. But what does that answer mean? What does 4, 0 tell me? These two lines intersect at 4, 0. Or another way of saying that is the point these two equations have in common. I will. So 4, 0 is the solution to this system of linear equations. And the reason it's the solution is because when I graphed these two lines, they crossed in one spot, and that one spot was 4, 0. And because I want you to have this in your notes, I'm going to go ahead and put a little box here for calculator steps. This is for the TI-84. I really want you to know the calculator steps for the TI-84 because, as I said, the TI-84 is the tool you will be allowed to use on the EOC exam. They're not going to give you a laptop, I'm sorry to say, and let you use Desmos. So I know Desmos is a better tool, and if you don't have a TI-84, it's really your only tool to use, but we are going to have to get familiar with the graphing calculators. So step one is you press y equals and input both equations. And we're going to put those in y1 and y2, which are the first two blanks. Step two is you press second, then trace, then 5. 5 will say next to it intersection. And then the third step is press enter 3 times. And then that will give you the answer. If you don't have access to a TI-84 graphing calculator, you need to send me an email and tell me, I don't have access to a TI graphing calculator. Those of you that are in class do have access to a TI graphing calculator. Probably it's on or near your desk. If you're at home and you don't have a TI graphing calculator, you need to let me know so we can make arrangements to get one to you. We need to start getting familiar with that calculator because that is what we will use on the EOC exam. So don't tell me right now because I'll immediately forget. But if you don't have access to a TI graphing calculator, please email me and say, I need you to give me a graphing calculator, and I'll see if I can figure something out. Okay, so this is an example of a system of linear equations that has a solution. The solution was 4, 0. But we also talked about how it's possible to have a system of linear equations that does not have a solution. Let me show you what that looks like. So solving a system, I'm going to put solving in quotation marks because you can't really solve it if there's no solution. So solving a system of equations right, linear equations, but that I'm not going to put linear because that's all we're doing is linear. System of equations with no solution. If I really wanted to be very, very specific, you're right. I would put system of linear. You know what? You've convinced me. System of linear equations. Now, of course, we don't have to do systems of linear equations. You can have equations that look like anything that might intersect each other, but we're going to keep things simple and only do linear equations for now. At the end of the year, though, we will deal a little bit with quadratic equations, which are equations that sort of look like horseshoes. And we'll talk a little bit about how to find systems of those. And I'll give you a hint. The answer is also put it in the calculator and find the intersection. Spoiler alert. Okay. So we, of course, are going to solve these by graphing because that's the only way I've shown you how to solve these so far is by graphing. So we need to graph these, which means we need them in slope-intercept form. And again, we lucked out. We already have one that's already in slope-intercept form. That's the bottom one. It's already y equals mx plus b. Okay. So this has a slope of -1/3 and a y-intercept of close -1 or 0, -1 as the coordinate. So I'm going to come down here and do a really terrible sketch just so I can get an idea of what they're going to look like. So 0, -1 is where my y-intercept is going to be. And then a slope of -1/3 means down 1 and over 3. So that'll be, I'm going to guess like right here-ish. That would be at 3, -2. Again, we're doing a very, very rough sketch just to get an approximate idea of what they will look like. Okay, let's go back and talk about the first equation, which we're going to do second because it was the one that was not already in slope-intercept form. So I'm going to come down here so I've got some extra space and solve this one for y. What should my first step be to solve this for y? What's a good first step? Yes, I do need to get the equation into slope-intercept form, which is a problem because of the x and the 3. Those have got to go. Okay, that's a good idea. So that's going to give me 3y equals negative x plus 12. It's still not in slope-intercept form, but it's closer. My only problem now is the number 3 in front of the y. How can I get rid of that? Subtraction would work if that was a 3 plus y. But because it's a 3 times, that's exactly right, Sierra. I have to divide. Very good. Or if you want it to be really fruity and weird, you could also multiply everything by 1/3, which would give you the answer in a pretty unusual way, which I support sometimes. Negative x divided by 3 is the same thing as negative 1/3 x plus 4. So what is the slope of that equation? Negative 1/3, and the b value is, which means the y-intercept is 0, 4. Okay, so again, I'm going to estimate 0, 4's up here-ish. And the slope of negative 1/3 means down 1 and over 3, which is going to be at 3, 3. Now it looks like from my really terrible sketch that these two equations do not intersect. And in fact, we know that they don't intersect because I told you when we started doing this problem, they wouldn't intersect. They're parallel. That means they'll never intersect. I could actually open up my graphing calculator and graph these to see whether or not they intersected so I don't have to go by my rough sketch. But there's a much easier way to tell that they're not going to intersect that does not involve me doing any extra work. Look at the slope of the first line, which was negative 1/3, and look at the slope of the second line, which was also negative 1/3. Sheesh, that was a terrible highlighting color choice. Let's try something a little lighter. So what does that tell me? They'll be going in like the same direction, you guys, which means I'm going to say because both lines have a slope of negative 1/3, I'm going to do m equals negative 1/3. They are parallel. That's the symbol for parallel, those two lines. They are parallel and will never intersect. Therefore, no solution. If it has at least one solution, that means they intersect. Lines could have more than one solution. Lines specifically could have a lot more than one solution. The solution's where the lines cross. Did you know that it's possible to have two straight lines that cross more than one time? you can have two completely straight lines that cross more than one time. Would you like to see what it looks like? So the first equation is already in slope-intercept form. So the slope of that first equation is 3/2. Good. The b value is -3. Very good. Which means the y-intercept is 0, -3. Okay, so let's do my sketch. 0, -3, I'm going to put about right there. Slope of 3/2 means up 3 and over 2, which is going to put that point at 2, 0. Now the second equation I could put in slope-intercept form, which is what I've been doing, but it's already in standard form. So there's another way you can graph equations in standard form besides putting them in slope-intercept form, and that is to find the intercepts. And the reason I want to do that is because I already have the intercepts for the first equation. The first equation, the y-intercept was 0, -3, and then I found out the x-intercept was 2, 0. Let's find the intercepts here. So the way you find the y-intercept is by replacing the x with 0. Three times 0 is 0. And if I divide both sides by -2, it'll be -3. So y equals -3. So that means my coordinate is 0, -3. Now I'm going to do the exact same thing, but replace the y with 0 in order to find the x-intercept. I put 0 for the y in order to find the x-intercept. Turns out 3x minus 0 is 3x. We'll divide both sides by 3, and Lord have mercy, what do we get? X equals 2. That means the x-intercept is 2, 0. What? You made an oopsie? Oh. So the y-intercept of 0, -3 would be right here where the first y-intercept was, and the x-intercept of 2, 0 would be right here where the second, or the first x-intercept was. Hey, look at that. What do you know about these lines? Not only are they together, they're the same. Because these two lines are the same. They intersect everywhere. Every single part of the first line is intersecting with every single part of the second line. I'm going to have to turn the hose on them. This is infinite solutions. Oh, then they wouldn't be lines if they curved around like that. That wouldn't make no sense. So when you are solving a system of equations, by graphing or any other method, any system of linear equations, there are three possible outcomes. Possible outcome number one is that the two lines have different slopes. Lines with different slopes would look like this. You'll have one line going one way, and you'll have another line going another way. And these lines have one solution. That's if they have different slopes. You have one solution. Possibility number two is they have the same slope, but different y-intercepts. Good. So the same slope but different y-intercepts are lines that are parallel. So for example, we have one line going like this, and we have another line going like this. Parallel lines have no solution. And the final possibility is that they are the same line. The same line, meaning they have the same slope and the same y-intercept. And that is infinite solutions. Yes, the infinite sign is great, in case you want to go to infinity and beyond. We would say these have infinitely many. Infinitely many solutions. Where do they intersect? Everywhere. Now, one of the questions you may be asking is, you've said multiple times, don't just go by your sketch, actually do some dang math on a calculator or in Desmos or whatever. Why? Why can't I just rely on the sketch? And the answer is sometimes the solution to a system of equations is not a whole number. Sometimes your answer is a fraction or a decimal. Let me show you what one of those looks like. I know, I'm excited too. So the second equation is already in slope-intercept form, so I'm good there. I'm going to go ahead and do some work with the first equation to put it in slope-intercept form. Don't say connect. The word is intersect, where they intersect. Let's subtract 6x on both sides. That gives me 2y equals negative 6x plus 1. And then what do I need to do? One more step. Divide by 2. Very good. Great job, Catherine. Divide by 2. What a smart kid. Your math teacher must be just ridiculously handsome. I can tell by how good your math is that it's pretty easy to concentrate in math class because that fellow is easy on the eyes. Okay, so here's my first equation in slope-intercept form. My second equation was already in slope-intercept form, and here's where I run into a problem. I could estimate negative 3x plus a half. I could estimate the solution there, but graphing 1/2 as a y-intercept, not going to be super easy. So here's where I would want to turn to technology. So on a graphing calculator, you would press y equals and put these two equations in. And if you don't have access to a graphing calculator, you will be stuck with the Desmos. I say stuck, it's not that bad. So I'm going to take out the two equations that I had previously, and I'm going to put in the first equation that we just solved, which was y equals negative 3x plus 1/2. And then the second equation was already in slope-intercept form, y equals 2x minus 5. On a graphing calculator, you do second trace 5 to find the intersection and press enter 3 times. On Desmos, it's just going to give you this gray point right there that you can hover over. Regardless of your calculator of choice, you should get the same answer, 1.1 and negative 2.8. So 1.1 and negative 2.8 is the solution. And hopefully you can see, I would have never in a million years gotten 1.1 and 2.8 if I was just doing a sketch on a piece of paper. There's no way I would have gotten that. So I'm going to go back to my notes here. And my solution is going to be 1.1 and negative 2.8. That's where the two lines intersect. There would be no reasonable way for me to get this without using a graphing calculator or Desmos. No reasonable way for me to get it by graphing. Now, next time we meet, I'm going to show you a way that you can do it without graphing at all, which is maybe a better way to solve it when you have a decimal answer. When you have a whole number answer, especially if you have access to a calculator, graphing is a really good way to solve these. You also definitely want to solve these by graphing if you have one or both equations that are in slope-intercept form. If they're already in slope-intercept form, you just type them into the calculator, and the calculator will tell you the answer, which is really handy. And I will post a tutorial a little later on how to use the graphing calculator. And again, be sure you message me immediately if you do not have access to a graphing calculator so that we can get you one. Got to learn how to use that thing. Does anybody have any questions for me related to solving systems by graphing?